Okay, let's see how this goes. Okay, so the connection there is not bad. Okay. Doesn't look too bad. So we'll see how it seems to be. A little bit on the drop frame side. All right, well, we'll see how this goes. Because I'm noticing some definite drop frames, but okay. So the funny thing is your question here has some interesting. Okay. Let's minimize that. Okay. The funny thing is, I should be able to stream at probably about 7,000 bit rate without any issue, but I have mine set at like 3,200. Just trying to maintain just a standard quality. But anyways, I'll have to work on it some more. Let's take a look at these questions. Now, you're supposed to determine if each pair is equivalent. Okay, send it to me. Yeah, after. Yeah, that's probably a better pen size. Okay. We've got 3x minus 2, 3x times 2x minus 1, minus 2 times 2x minus 1. Okay. So the funny thing about this is, do you know how to distribute terms? Does the term FOIL make any sense to you? Or factoring? Or distribution? Okay. Let's factoring. Okay. So I'm going to ask you then, if I have a number, let's say x squared plus x, and I want you to factor that, what would you do? No, there's no perfect square here. Nope, I just want you to take out something that's similar in both terms. Just straight, easy factoring. Yeah, you would take out an x. So if we take out an x, what are we left with on the inside? Well, not x plus x. It would be x plus 1. Because there was 2 of them here and 1 of them here. So we have, if we take out 1 of them and we multiply back in, we need to get back the same, right? So then that would be x times x plus x times 1. So we would get x squared plus x. That's just regular factoring. Okay. Now the only thing that's different between your question and my example here is that it's just using a little bit known as a function as a factor. So we can do both directions. On this one, I said factor out and then multiply back in, right? We can do the same thing with both of these. So let's do the second one first, just so you can see how it references with the factoring. 3x, 2x minus 1, minus 2 times 2x minus 1. I'm going to rename this question, okay? 3xu minus 2u. I want you to take out what's common between these two terms. Well, not the 2, just the u. Just the u. So if you take out the u, you see that there was a 3x here and a 2 here. Yeah, I'll wait for you to write it out. Close. No, you're close. You're close. So you took out a u, but there's still the 3x here. So we have the 3x, which you were right. And then what's left, we had minus 2u, so minus 2. Okay. In truth, all I did was let 2x minus 1 equal u. So if I just replace u with 2x minus 1, we're back. And it doesn't matter which order, because a number times a number can be replaced. So 3x minus 2 on the left is the same as 2x minus 1 on the right. So I am going to write confused? Okay, let's go back. Okay, this line right here. Do you see how if we take out both the u's, we take it out in front like that, and what we have left is the 3x that's in front, and then minus 2. We good with that so far? Okay, great. That's exactly what I needed to hear. Yeah, we're good. Okay. So I'm going to erase this again. What do you see that's different between my question and your question? Because in my question, I just wrote 3x times u minus 2u. In your question, we have 3x times 2x minus 1 minus 2 times 2x minus 1. So what is the difference between these two equations? We solve this to 3x minus 2. You're not sure? Okay, okay. I'm going to draw just a one quick little box then. These u's and this. It's the same. Look, we have 3x times u minus 2 times u, and then the 3x times the same thing. It's like, see, how else would I put this? You know how to do the top one, correct? The funny thing is this is exactly what you're doing. Here, let me erase this and go back for a second here. So what we're doing is we're just taking out what's similar, right? It doesn't matter what it is. I could say that a times b plus c times b, and then we take out what's similar, we take out the b, so then we're just left with a plus c. You're good with that, right? Okay. Yeah, so just the same as like any number, if you take out what's common, the b's are common, so you take it out, and whatever you have left is still there. So you have an a that's left plus a c that's left. Okay? Now, it doesn't matter as long as it's still similar. So I can say a times x plus 1 plus c times x plus 1. Don't get confused about what the x plus 1. Just realize that it's similar in both terms. So you can take it out. It's the same in both terms. So we take out an x plus 1. And what do we have left? We have an a and a c. Same thing. A plus c. Okay, that makes sense. We're just looking for what's similar in both terms. Okay, in our question, we have 3x times 2x minus 1 minus 2 times 2x minus 1. Okay, now what's similar in both terms? No, not the x's. The whole thing, the whole 2x minus 1 is the same. Do you see that? Do you see how there's this one and this one are the same? Well, there's nothing to cross out. We're just factoring, right? If there was a division or something like that, then we'd be crossing out. But there's nothing really to cross out. We're still just factoring. So just the same as we did with this A and B example, we're doing the same thing here with our question. Does that make sense? It's the exact same steps. Well, you're not taking anything away like that. So look, again, if I did the exact same thing as before by writing it in u's, so I don't really care about this 2x minus 1 thing. I'm going to write 3xu minus 2u. We did this before. It's the same thing, right? We took out just a u from both terms. We brought it out in front. And then what we had left was the 3x minus 2. Okay. So if we're taking something out of both terms, we still have what's left, which is the 3x minus 2. Are we good with this part right here? Okay, let's see. Okay. But you're overthinking it. Okay. Okay, you get the one with the u's. Okay. Now, just replace u with 2x minus 1. Literally just replace it, and you're done. Okay. See how I just did this right here? The whole thing, the whole 2x minus 1 is just the letter u. Okay? I'm just making it one letter so it's easier to see. We literally just pull out the 2x minus 1, and then what we have left is the 3x minus 2. Yeah, the light bulb, right? Well, you're not canceling out. You're taking out the right language, because if you say it to somebody else, they'll be confused, you know? Yeah. So, for example, 2x times 3x minus 4 plus 3 times 3x minus 4. Three x minus 4 and 2x plus 3. You got it. That's exactly it. 3x minus 4 and 2x plus 3. Okay. I'm going to give you one that looks a little different, but it is still pretty much the exact same. 3a squared y x minus 1 plus 3 x minus 1. If you ever want to like type exponents, you can use the little hat symbol if you want. But yeah, you would take out the x minus 1 and you'd have 3a squared y plus 3. But you're not quite done yet. The reason why this is a little bit trickier is because you can also take out the 3. This 3 can be taken out as well, and that would actually just go in front. So you would get 3, not equals, 3 times x minus 1, and then a squared. Well, because a is not in both terms. No. The a is squared, but not the 3. Okay? So this is 3a squared, which means we have a 3 times a squared. So a is squared, but not 3. If it was 3 squared, then I would have written 9. See the difference? Because there's no a in the second term. You see? I'm going to erase this and kind of rewrite it for you a bit. But there's no a here. It's only 3. If you had an a in both, then you would take it out. No, there's no a to take out. There's only an a squared here, but there's no a acting on this second 3. There's no a here. Okay. Here I'll just write this answer out. 3x minus 1 a squared y plus 1. And I'm going to go back up to the top, start a new page. Okay, another question. I want to think of something that, no, I can't use functions. You don't know what they are yet. I'll just do something simpler then. 3a squared. Yeah, okay, sure. Okay, so we did A, right? So we should do B. Or let's just quickly go over A again, I guess. Three x times 2x minus 1 minus 2x minus 1. Okay, I'm just gonna go through this really quickly over again. In here, we just factored this out. Yes, they are equivalent, because when you factor it out, you get the same thing that you started with. But you can also go in reverse. Yeah. Go for it. Mm-hmm. You got it. Pretty easy. No, because remember that 2 times 7 is 14, but that's also 7 times 2. Same idea. Multiplication can go either direction. Doesn't matter the order. Sure. So remember that multiplication, it doesn't matter which order it is. 2 times 7 is the same as 7 times 2. So when we have two terms multiplied onto each other, it doesn't matter which order, they're the same. So you can just change the order, and it doesn't matter. Great. So are you ready for the second one? The B question then? Okay. Now, I'm going to actually make you redo the first question, but go the other direction. Okay? Just so you can see how it will work both ways. We started with factoring. Now we're going to go with the other direction. Okay? Just to make sure you know. We're going to start with the 3x minus 2 times the 2x minus 1. Okay, so this is exactly what we do. We need to multiply 3x onto it, and then we need to multiply the minus 2 onto it and add them together. Nope. You don't have to do any of that. Okay. What we're going to do is we're going to break it up. We've got a 3x minus 2 multiplied onto something. Okay. If I say what's 3x minus 2 times the letter u, what does that give you? But now instead of u, we have 2x minus 1. Okay. Remember, so with this one, you did 3x times u, and then you did the minus 2 times u, right? That's how you got this part right here, and then this part. Okay? You just multiplied the first term onto u and the second term onto u, right? Exactly. Okay. A is you. Yeah, we're helping out here. Okay. So now we're doing the exact same thing, but instead of a u, we just have this whole term. So now do the same thing where you have the 3x minus 2. You're going to take that 3 and you're going to multiply it on to the whole thing, 2x minus 1. And then what do you get? No. Remember, we were going to do the whole thing. So I'm going to, not just the 2x, but the whole thing. No, just don't multiply it through. Just you write it out one step at a time. So you would still have that 3x. So you write your 3x. And then what is it multiplied onto? Yeah, okay, we've got the first one, 2x minus 1. And no. Now, the second one, we have a minus 2. Then that whole thing multiplied onto the whole thing. You keep each term separate. So we had the 3x, which is the times 2x minus 1. Now we have minus 2. Yeah, there you go. So you don't try and multiply everything out. Write down each step. Okay. You want to try another one like this? Okay, the big question then. Big question. Okay, we've got x minus 4. And here, I'll write this whole thing. X minus 4. 2x squared plus 5x minus 6. And 2x squared x minus 4 plus 5x x minus 4 and minus 6x minus 4. Okay, which direction do you want to go? Do you want to try the factoring or the distributing? Well, we just did both, so we could do the first way where we go and factor out the x minus 4s. Do you want to try that first? Yeah, okay. So, what is similar in all three terms? Yeah, that was it. Can you go the other way now? I basically can just kind of sit and wait for you to write it down because pretty sure you got it now. You're missing something there. So the only thing that you're kind of missing here, so you did this part, right? When you did the factoring. Now you're going to do this part. So we're going to go x minus 4. And nope. We've got 2x squared plus 5x minus 6. Same thing as we did earlier up here. We did each term multiplied on, yeah? We're just going to rewrite this to make it a little easier for you. Because I want it to become the same as the other one. I'm going to write it in the other order, just so you can see. 2x squared plus 5x minus 6, then times x minus 4. Okay? Now do it the same as this one up top. Yep, that's the first term. 5x times x minus 4, that's the second term. Minus 6x minus 4, that's the third term. There you go, bud. I don't think I'm that awesome. I'm just kind of regular, helping out where I can. Basically, whatever the common factor is, then you take that out. And then whatever you have that's left, you write down what's left. And you're done. That's factoring. And then what you just did there was the distribution. I'm not sure what they explained it like. This is basically just multiplication and factoring. No, I don't need to go. I'll be here for a while. Let's see them, bud. Ironically, the question has the answer. It's a one-step problem. So I'll also save these notes and send them to you on the Discord when we're done. Why is your images so small? Okay, you have a bunch of factoring problems here. Okay. Well, the first one, I think you pretty well know how to do it. What's the answer to the first one? That's common, the x minus 3, so write it all out. I don't want you to use the cross out term because that's technically not correct. There's nothing to cross out. And so I don't want you to mess up. Well, you see, that doesn't make any sense. There's no crossing out. You're factoring them out. So what does the factored form look like? No, not canceling. There's nothing canceling. Like, cancel and cross out, that all means that things like disappear, that they go away. You're not actually removing anything from here. You are just factoring. Okay, you're just moving from one place to another. Like, literally just factor is the word. Or you could say take out. As in, like, you are taking something from one side to another, or like outside a box, or taking something out. Term. So what would it look like when you're done writing it down? Well, not the answer. That would be one of the things, x minus 3. But then you still have, because remember you took out, you removed the x minus 2. So x minus 2. And then what do you have left over? You have the x minus 3. Just remember from before, just like the 3xu minus whatever it was. 2u. Yeah, nothing has changed. Yeah, this one is actually just simpler than the ones we did previously. Yeah, like the word factor, factoring, and all that stuff literally just means doing this process. This is factoring. In the other one, it wanted to know if they were equivalent. Well, you found out they were equivalent by factoring. No. Factor is, so another thing, so like 6 is 2 times 3. These are called factors. Okay, B is a different kind of problem. It's a little more complicated. Yeah, exactly. You find the two numbers. We have x squared minus 11x plus 28. Right, 28, yeah. You're definitely on track. You know this stuff already. So what I like to write is two numbers, a times b, that's 28, and two numbers, a plus b, is equal to minus 11. There's not really any tips. This is actually just kind of a process. So you just kind of go through the process. because it's like, it's just take out the greatest common factor if there is one, then do the multiplication to see if you got the two numbers, and etc. Like, if there's tricks to more complicated things, but not really factoring, it's just kind of a process. Like an algorithm, maybe. There's no point. Don't use decimals, because that's not actually factoring. We want to use whole numbers. And at most, we would use fractions, but this isn't a fraction thing. So we're not doing the factors of 11. We're finding two numbers that add together to give you 11, right? Because we need two numbers that multiply to 28, but add to 11. Like you even said it earlier. No worries. Okay, let's start with the two numbers that multiply to give you 28. What are all the factors of 28? Yep, 4 and 7. Okay. You've got 4 and 7. Now, are they both positive? Is one of them negative, or are they both negative? Yeah, we have a -4 and a -7. Exactly. You got it. So what do you do now? Yeah. So my question though, because I've seen it two different things. Yeah, I don't know. I wonder if I can turn that off. If it's a thing that I can actually mess with. I don't see it at the moment, unfortunately. Yeah, I know on Twitch it works like that. I'll have to mess with some settings and then I'll see if I can get it to work better. Because I know Twitch is... I have so many drop frames on Twitch. Like, it's all fairly time dependent too, almost. Anyways. You know that your answer is x minus 4 and x minus 7. It's literally like either settings or the connection to the servers itself. Anyways, for these factoring questions, did you learn it so that once you found the numbers, you know what to write in? Or did you do like x squared minus 4x minus 7x plus 28 and then group them and factor? So then you would take out an x. And so you would have x minus 4, take out a minus 7, and then you'd have x minus 4. And so you would have x minus 7, x minus 4. Okay. Okay. Because, yeah. Then your teacher did it the quick way. Truth be told, you can do it this way if it's more complicated and harder to see. I have had a few American students that had to learn it this way rather than just doing the numbers. So it depends on what your teacher does. We don't need to do this if we don't have to. If you've got the numbers, you're done then. Yeah, but Canadian system seems to be a little different for some reason. I'm in Saskatchewan, bud. We're finally warming up. All right. Are you ready to do C? No, that's factored. Okay. In C, what can you do first? So I'll give you a minute. You tell me what we need. Yeah. Honestly, but you're not the first to say that. This thing that I'm doing here is a lot of one-on-one that people don't get. So 2 numbers that add to 10 and 2 numbers that multiply to -8. Not quite, no. So the difference with this question is this 3. So the real truth is you need to have 2 numbers that multiply to give you this 3 times 8. So you need 2 numbers, I'm going to call them x and y, that multiply to give you 3 times -8. I'll just write it. -24. And then you need the 2 numbers that add together that give you -10. So 3 times -8. The -10 is still here. You got that to begin with. 2 numbers that add to -10. It's just that 8 changes because of the 3 on the front. Yeah, only with the multiplication. Yeah. So, like, yeah, -12 and 2 works because -12 plus 2 is -10 and -12 times 2 is -24. You got it. Well, okay. So here's the thing we need to run into. The reason why in the previous question I talked about this thing that your teacher doesn't do is actually really useful for finding out the answers to these kinds of problems where it's not so straightforward. So I'm just going to walk it through you real quick to show you what the answer should look like and see if you can draw any conclusions from it. So we've got a -12 and a +2. So I'm going to write 3a squared from the beginning, then -12a plus 2a minus 8. Okay? So all I did was take that -10 and rewrite it with the 12 and the 2. You good so far? Okay. Now I'm going to group them by just putting brackets around them. No big deal. And I'm going because the 8 we leave alone. We're only changing the minus 10. Just like in the other one, we only deal with what's in the center. So the addition of the two numbers, those are the only two we're going to split up. Okay. So now we're going to factor each of these. Just like we did before, we're going to take out what's common and then see what's left. We've got 3a squared minus 12a. So 3 and an a are common. So we're going to take that out of that. We've got 3a. So what do we have left? An a minus 4. Are you good with the first one? Okay. And then we're going to take something out of the second one. Well, there's a 2 that we can take out of it. So we're going to just take out a 2. So 2a minus 4. Now you should be able to recognize this factoring from those first questions we did. So I want you to write down what this turns into now when you factor it out. Yeah, a minus 4 and 3a plus 2. That's exactly the answer. Now, the problem is, it's hard to go from minus 12 and 2 to 3a plus 2 and a minus 4. It is what we got. The only difference is we have to figure out how to get there. So that's the problem when it comes to numbers where we have something in front. So that's the problem, right? It's not self-explanatory to get the minus 12 and the 2. We got it originally, which was great, but going from minus 12 and 2 to just straight up knowing that it's going to be a minus 4 and 3a plus 2, that's not very self-explanatory, is it? Now, the question is, did your teacher have any notes on these types of factoring when you had a number that was not 1 in front of the squared value? You're not going to suddenly become Einstein. You're going to be like, oh, you actually learned how to do it. What were the notes that your teacher gave you to change these numbers into these numbers? Okay, let's see. What was it? Yep. That's what we did. We multiplied. Yep. Then grouped them. Well, we did that to begin with. We took the first number and multiplied it by the last number. That's how we got the minus 24. Then we found out our two numbers, the 12. Sure, send me a picture. If the first number, then multiply the first. Yes, there it is. If there's nothing you can take in common, then example. Wait, what? Okay, let me look and read. Oh, she didn't actually describe. Okay. Okay, so ironically, she did do this right here, where we added and subtracted, and we grouped them. She did do that, but she didn't explain why or how. So okay, so basically you just kind of need me to tell you how to do her way. Makes a little bit of sense, yeah. So what she did there is the same thing that I did here. It's just she didn't go through and solve anything or tell you why. Okay. Let's see. Do you have another question that's like this? Yes, you do. Okay, let's do D. Let me know if you want me to do this question again or if you want to do D. I know you don't understand it yet. I'm ready to go through it again, like a couple times to see if you can kind of get the gist of it. Just let me know if you want to do this one again or if you want to do the next one. Sure. I'm going to do this on a blank page and kind of go through it all over again. Uh, 3a squared minus 10a minus 8. Okay. So the first step was realizing that there's a 3 in front, so we need to multiply the first number by the last number. Okay? So we know that we need two numbers, x and y, that give you to minus 24. Okay. Hey, row time. Okay. Then we need two numbers that, well, need to add together to give you minus 10. Okay? You're good on this part? Okay, good. You know that it's the 3 times the minus 8 to give you the 24, and then you got the minus 10 from right here. Okay. Then you found out that the two numbers we needed was minus 12 and plus 2, right? You're good on that so far? Great. Okay. Now, we've got minus 12 and 2. Those are two numbers that add together to give you minus 10. Okay? So this minus 10 is now going to be split up to minus 12 and plus 2. Okay? So we've got 3a squared from the front. Now we're going to split it up to minus 12a. Yeah. Plus 2a. And then we've still got the minus 8 on the end. Okay? Are we good up to this point? Perfect. Okay. The next step is we're going to group them together. We're just going to group the first two terms and the second terms. So I'm going to write it again. 3a squared minus 12a. And then add the second two terms, 2a minus 8. Okay. Good with the grouping now. Easy enough? Okay, good. Now, remember we were doing factoring, so we need to take out what's common in the first set of parentheses. So what's common in the first set of parentheses? What is in 3a squared, but also in 12a? The A's, yep, there's the A's, but there's also a 3. Well, you messed up a little bit. You can take out the 3A. So then what do you have left on the inside? Yeah, A minus 4. Okay. The second set. What can you take out in the second set? Yeah, just the 2. So what are you left with on the inside? A minus 4. You're already there. Okay. Now, just like those questions we did at the very beginning, very first thing we did, what can you take out of both of these now? Yeah, you just messed up the sign. So 3A plus 2 and A minus 4. You got it. This is the group factoring that your teacher did underneath that little statement there. Because we're not multiplying it out. Look, the 3A and the 2 form this factor, and then the A minus 4s. Right, good. Yeah, nothing's changed. This is all the same stuff. The only thing that we added differently was breaking up the minus 10. Everything is still the same. Nothing's changed. We're done. This is it. That's factored. This is what we needed to achieve. Factored form. Nope. We needed those to get to factored form, but that's not the answer to the factored form. yes, it would matter because remember, these two statements are equivalent. This 3a squared minus 10a minus 8 is the same as 3a plus 2 and a minus 4. So for example, if I wrote x minus 12 times x plus 2, and you multiply those out, you get x squared plus 2x minus 12x minus 24. That is not 3x squared minus 10x minus 8. So, do you understand how to do C? This question. This was question C. Okay. You want me to leave you to it? See if you can do question D? Okay. Okay. Minus 9x minus 3. So an explanation. There is a list of rules I could write down, but then I need to make sure that you would understand the language that I would use. Yeah. Okay. Step 1. Factor GCF. So I'm going to write actually the steps for this one. I think I'm going to do it step by step. And you know, I might even just do a new page and we can come back to it afterwards. So we've got 30x squared minus 9x minus 3. Okay. Step 1 is factor here in this question. Three. Perfect. Okay, so what does it look like when we factor out a 3? We still need to factor out a 3, just like we've always done before. No, we're not quite there yet. We need to write it out. Start with the 3. If we take a 3 out of each term, what do we have left? we've got the 10x squared minus 3x. Well, if we take away 3 from 3, we would just have 1 left. So minus 1. Right? Because it's the same as 3 over 3. We did, but we just did it with 2 terms instead of 3. This time we're doing it with 3 terms. It's the same thing. Remember, whatever you take out, if you can multiply it back in and get where you started from, then you're good. So do you see how to get the 3? Yeah, so this is the first step, is factoring the greatest common factor. We're just getting there. The other questions before didn't have one to take out to begin with, so we kind of just, we're done. We skipped the step. Okay, so now I don't need these arrows anymore. Second step. Multiply how do I want to write this? If I write, I'm going to write the equation in general and then write the step for it. So we have ax squared plus bx plus c. Well, see, the thing is, it's not just numbers. It could be like a variable as well. So for example, if this was like x to the power of 4, x to the power of 3, and an x squared, you could take out an x squared and then you'd still continue. So I'm gonna write numbers and variables that are common in each term. Does that make sense? If I write numbers and variables that are common in each term? Well, I don't know if even's the right word to say. Just like common in everything. Yeah, sure. As they can all fit into one number. So let me just see if I can understand you here to make sure that you understand. If I give you an example. Yeah, okay. Let's keep going. Okay. The second step, I'm gonna write the equation in general so that I can actually write out the step a little easier for you. So in general, we have ax squared plus bx plus c multiply a times c. Okay. So for us, we have 10x squared minus 3x minus 1. So multiplying a times c is multiplying 10 times minus 1. Does that Is that able to follow along there? Great. Okay. Step 3. Find two numbers. Yeah, no worries. I'm gonna think of a way to write this down for you. I'm gonna write u and v such that u times v equals a times c and u plus v equals b. I'll probably have to explain it to him, but no, I don't need to write it again. So we have minus 10. And b is negative 3, so need u times v equals minus 10 and u plus v equals negative 3. Okay, no worries. I just kind of wrote down a little things. In step 3, can you understand what I mean by find two numbers, u and v, such that when they're multiplied together, they give you that a times c that we had, and that they add together to give you b? Is step 3 kind of clear enough for you to read and understand? Perfect. Okay. Now, what are the two numbers? No. We need to find the two numbers such that they multiply to give you minus 10 and add to give you minus 3. We haven't done that part yet. You're jumping the gun a bit. Forgot to find the two numbers. So first off, what are the two numbers? I know you know them. Yeah, no worries. Yeah, -5 and 2. So I'm going to write just -5 and 2. Okay. Step 4. Split up. Oh, wow. I can't even write up properly. Split up B into your two numbers. Okay. So we still have that 3 in front. We still have 10x squared. But now this -3 is now -5x plus 2x. And we still have a -1. Step 5. Group and factor. There. Are we good up until here? Perfect, perfect. Okay, so then I'm going to write this again in another step. We've got 10x squared minus 5x plus 2x minus 1. So what can we take out of the first two? Okay, bud. So let's see. Let's see your factors. What can you take out of the first brackets? Not quite. You got one, you're missing another. You can still take an x out of both of them. So you would have 5x. So let me see you write what's remaining. Not quite. Try again. Remember, when you multiply it back through, you can do it. Yeah, come on. Not quite. So remember, when you take out the 5x, when you take out the 5x, whatever you have on the inside has to multiply back in to give you this 10x squared minus 5x. So if we multiply the 5x back in, we need to have just a 2x, which is right. But then to get 5x, we need to subtract 1. Because if we multiply 5x onto 2x, we get 10x squared. And if we multiply 5x onto minus 1, we get minus 5x. Yeah, there you go. Okay. there's nothing to take out of the 2x minus 1, so we'll just leave it as 2x minus 1. Okay. We're good here? Okay. Next thing. This is just like we did before. Nope, we're not done. This is just like we did before, where we factored out a common term. So what is the common term? Well, not quite. So you take out the 2x minus 1. That's right. So we've got the 2x minus 1. So remember, whenever you multiply back through, you need to get what you started with. So you had that 5x, but there's a 1 here that's not written. So you would need that 5x plus 1. Do you see how that would work? Okay. This is done. This is factored. So the only issues I see you got with this is potentially forgetting that there's ones. So like this one in here, you forgot to have that minus 1 in there, and you forgot this one down here that you would forget about. So if you just watch for those, you shouldn't have too much of an issue. Deserve more fame. Honestly, bud, some people are kind of making fun of me for my Instagram. My friends kind of laugh at it. It's like, why are you so popular on Instagram? All you do is post math notes. Truth be told, all I really need is to have a better connection or something, and then I can really do this much better. If I had like great quality all the time, not dropping frames and not having all this, it would be so much better. But then it'll come. Okay. Are you ready to do the next question? Surprisingly, you're not the only one who said that. Okay. Next question. Question E. I'll go back one page so we can use up this extra space. And besides, I'm going to send you all these notes afterwards, so not to worry. E. Now, you were already talking about this. And I think you, since you were already talking about it, you probably already know how to do it. So tell me, how do you do this one? 16 minus 25x squared. Honestly, it's lots of the time that's what happens when I do my Discord calls too. I write on the screen and they walk me through it. Yeah, exactly. Difference of squares. So, what is the formula for difference of squares? You tell me. Okay. So, oddly enough, on my Instagram, I did write these down a long time ago, though. Okay, let's see what you got. I don't know why that would be held, but yeah. It's not quite like that. So, difference of squares is this a squared minus b squared form. Okay? When it is factored, it is literally just a minus b times a plus b. And that's it. That is the formula. Either direction. Either you start with it in this form and you get the squared, or you start with the squared and go back. They're both the same. Okay, cool. So, what does this turn into then? If we have 16 minus 25x, what's a and what's b? We'd literally just kind of factor it just by using this formula. Well, you still got this x squared. So the question is 16 minus 25x squared. So we have a squared minus b squared. So if I rewrite this, this is kind of like 4 squared minus 5x squared. Do you see how the 16 changed to 4 squared and the 25x squared is 5x squared? Yeah, basically. Okay, so this is A and this is B. So now fill out our formula. And I'll let you write it. We haven't finished it yet. All I did was say that we rewrote it in this form. So this is still the 16 because 4 squared is 16. And this is still 25x squared because 5x squared is 25x squared. We need to write it in this form that's factored. We need to write it in this form. Because we are factoring. That's what the question's asking us to do. Factor it. Well, no. So look at what we have here. We have A and we have B. And we need it to be in this form. The A minus B times the A plus B. We have 4 minus 5x, and then 4 plus 5x. Like, I could give you another example and you'd still do the same thing. So do you see how we went from the 16 to the 4 and the 25x squared to the 5x and then plugged it into our formula? Yeah, that's the whole answer. That's it. That's factored form. Okay. Now, funny story. F is the same thing, even though it looks way more complicated. So are you ready for F? Okay, okay. How about instead of F, I'll make you do another one. I'll make you do another one first, just so you can like practice the difference of squares. 1 minus 9y squared. No, wait. Yeah, sure. What is this in factored form with the difference of squares? Well, you can't forget the y. So write it again. So like you said, you had 1 minus 3y and 1 plus 3y. Okay. Good. I'm going to tell you, what if we just rewrite y and do this again? So this is 1 minus 9, but instead of y squared, we're going to have 2x plus 1, or 2x minus, 2x plus 1 squared. Now, what do you have? Now, don't simplify, just tell me what to write first. Yeah, 1 minus 3 times 2x plus 1. And and then you've got the 1 plus the 3 times the 2x plus 1. Do you see how that, even though this looked more complicated, it was still the same thing? Perfect. Now you can do F. Yeah. I don't even need to write a new page for it. I think you can do it right here. 4, 2 minus a squared minus 81. Let's see you do it. Two times 2 minus a minus 9. This is probably what they'd want you to do, is simplify it. So you're going to multiply the 2 and combine like terms inside the parentheses. So we've got 2 times 2 minus a minus 9. So what would I write next? So we're just going to do the first term though. No, we're not going to factor. We're actually just going to multiply the 2 inside, and then we're going to add like terms. So like 2 times 2, then 2 times a, and then add. So what would we have? Remember, this is just distribute the 2 onto the 2 factors inside. This 2 out front and multiply it onto each number. So what does that equal? We did this earlier. We did it with more harder numbers, actually. Yeah, 4 minus 2a. So we have 4 minus 2a, and then we have a minus 9. So what's 4 minus 9? Got minus 2a minus 5. Yeah. Okay. There's a minus in both of them, so we can factor out a negative 1. So this will be a negative 1 times 2a plus 5. Are we good with that? Yeah, it's normal. That's what I'm here to do, is help with high school stuff. So all I did was realize that there's a negative in front of the 2 and a negative in front of the 5. So I can take out minus 1 because we don't like to leave so many negatives around when factoring. So then just taking out a minus 1 makes them both positive. Does that make sense? In truth, you would have to do that, yes. Because it's not done. We need to be fully factored form, and that's not done. We could still manipulate it. When we have nothing else we could factor, that's when we're done. So we only did the first term, though. We still need to do the second one. Yeah, we can do a practice. But after we finish this one. We haven't finished yet. Because we only did the first one. So I'm going to write it out. Minus 1, 2a plus 5. And now what's the second one going to be? And I'm going to write it again. 2 minus a plus 9. 4 minus 2a and then plus 9 gives us what? I'm going to write just minus 2a plus 13. Okay. Now the only thing I'm going to do with this is I don't like leaving the negative in front, so I'm going to take out a negative again, negative 1. So then I have 2a minus 13 instead. So I'm going to write minus 1 in here, and then 2a minus 13. And then these minuses multiply to give you a positive. So then we're just left with 2a plus 5 and 2a minus 13. There's more steps this time because it's a more complicated problem, but it's still all the same stuff you've done in the past. All the same. Nothing's changed. You just had to do it a couple times instead of just once. This would be the final answer. I know it doesn't look like it, but that's the final answer. 2a plus 5 and 2a minus 13. So I don't need to write these. I'll erase this right here. And then I'll write a note. Two times 2 minus a minus 9 equals 4 is 2a minus 9. Um, 2a minus 2a minus 5. The minus 9 and the plus 9? You even said that from the 81. Because the original question had the 81. Okay, so the difference of squares part. Remember that you had... I'm actually... Okay, good. Yeah. You're right. You got it now. What do you mean by at the end? Because you already did it, and you just further simplified. Because you walked me through it. Do you need to go through it again? Or another problem like it? Okay. Good. Because there's not much to these. There's nothing extra. This is all pretty well the same. Great. So do you feel like you got enough so that you could study for your test? No, I got time. I'm just going to use the washroom though. So if you could just send me some of those problems, I'll be right back. stop for a piece of an arrow bar. Okay, let's see these problems. Simplify and state restrictions on the variables. Yeah, sure, no worries. Okay. Okay, bud. What do you want to do for these? Now you want me to kind of watch over you to do them. So you want to just tell me what to do and then we'll kind of go from there? Okay. So let's do number A then. Or the first one. Okay. Honestly, it's kind of random. I don't really have an set end time or start time right now. Mostly because you has already noticed that the consistency is not very good for the stream, so I don't really have a consistent schedule yet. Yep. So, factor the denominator. Yep. So what do you get for the factors for the denominator? I'll let you do that on your own. I just want you to tell me what the factors are. So what does the denominator turn into? Tell me what the factors are. Well, think about it. If you'd had a minus 4 and a plus 1, you're going to get a minus 3. So it should be a plus 4. The 4 should be positive and the 1 should be negative. That's just a simple sign mistake. Okay, what next? So when you cross out what's the same on both the top and bottom. For example, 6 is 2 times 3, right? And if you have 6 divided by 2, that's 2 times 3 divided by 2. So you cross out what's the same on the top and bottom. Does that make sense? Wait till we get into our calculus lesson. I'm kidding. I might do a post on calculus today. Yeah, you cross them both out. So you have a plus 4 and a plus 4 cross out. So then you're just left with 1 over a minus 1, right? Okay, now the question says state any restrictions. Because it's always implied that everything is multiplied by 1. Oh, nice. Everything is multiplied by 1, also divided by 1, because 2 times 1 is 2. And 2 divided by 1 is 2. It's always implied. Okay. Well, then your teacher didn't do it right, because there's nothing on the top, so there has to be a 1 over there. You can't just write a minus 1, because that's not right, because there has to be something over it. I think you might be just misreading what your teacher put. For the same reason that you would write 1 over 2, 1/2. If there was something still on the top, you would still write that. So, for example, if I still have on the top, so you still had to write a 1 over a minus 1. Does that make sense? Yeah, okay. So there's still the one thing about the restrictions on this. You got one of them right, but the other one not so right. A can't be minus 4, which was right. I don't know. What's the Nelson textbook? I did buy, like, they're supposed to be the curriculum textbooks from the whatever the national website is, but I don't feel like I got the most recent ones. Give me a second. This was the one that it had me to buy for grade 9, grade 10, grade 11, and then grade 12. I know it's mirrored, so you won't see the proper text. Anyways. There's still the, this other one, a can't be -4, but it also can't be 1. Interesting. Well, I'll save this PDF. That'll help me fill out the rest of the stuff I need. So it can't, it's not that it can't be 0, it's just that the denominator can't be 0 itself. So you would set a plus 4 equal to 0, and you would set a minus 1 equal to 0. Because if a is 0, you still get a number on the bottom. So that doesn't matter. It's only when the denominator is 0 that you have problems. It's not that the number can't be 0, it's that the denominator can't be 0. You need to write the restrictions before you write the final answer. Because when you cross it out, you're missing that 4. So, like, the best way to say it is the denominator can't be 0. Why can I not spell all of a sudden? Denom. There we go. So, like, for example, if we plugged in a equals to 0, it doesn't matter. We'd get some fraction. Yeah, the -4 and the +1, because a minus 1 equals to 0. So when a is 1, then it's 0. See how those numbers came out? Okay, perfect. Now let's do the next one. Yep, numerator is difference of squares. So what is the numerator turn into? Well, the denominator can be factored still. So you're not quite done. So you would have x minus 3 and x plus 3, right? You should probably write it like full out. Write the parentheses so that I kind of get what you're writing a bit better. Okay, and then what is the bottom? Well, you're going to take out the 5 from the bottom, right? So take out the 5 because 15 is 5 times 3. So if you're going to take out a 5, what are you left with? Three minus x. But 3 is not in 5, so that you can't do that. I think you're just mixing up your words. Yeah. Exactly. Because think about it this way. When you multiply back in, it has to come out the same. So 5 times 3 is 15. 5 times negative x is negative 5x. You have to be able to come back to where you started, no matter what you do. You might always want to test yourself by re-multiplying back out what you took out. Because, yeah, we can't cross it out like that. We need to take out another minus sign from this. So we'll have a minus 5. And then we can, if we take out a minus sign, it'll be x minus 3. So do you see how taking out the minus sign will flip the order so that we can now cross it out? Yep. So nothing, remember when we're factoring, nothing disappears. It just gets moved around. So that if you put it all back in, it comes out the same. Okay. What are the restrictions now? Yep, we can cross out x minus 3 and x minus 3. So it's good. Good. X can't be 3. And what are we left with? X plus 3 on the top. There would be a minus 5 on the bottom, but we don't like writing a minus sign on the bottom, so we can just bring the minus sign up and write it on the top. Do you see how that worked? So I didn't cross out the minus at all. I just moved it. As long as you're referring to the minus that's on the 5. I'm not sure what else you would be referring to. So I only crossed out what was similar. So you see this x minus 3 and x minus 3 are the same. So those two could be crossed out. There was nothing else that was the same. So nothing else got crossed out. Yeah, just the stuff that's the same. If there's nothing else the same, it just gets left. Okay, C. Again, these C is just another factoring question and crossing out. So what are the factors? So tell me what the numerator turns into. Yep, that hasn't changed. It's still all the same. None of these, it's actually all the stuff we have done through today are all the same. Nothing's changed. You're going to do the same thing for everything of this form. Yeah. So write it out. What is it going to be in factored form? Like with the parentheses and the variables, everything. Write it out for me. Yeah, exactly. X minus 3 and x minus 2. Now the denominator. Same thing. Write it out for me. Good. X plus 5. X minus 2. Okay. Now it's in factored form. What are the restrictions? Well, what happens if x is negative 3? Nothing really happens. 2 and negative only when the denominator is equal to 0 that we run into issues. It's okay. All that matters is you understand the concept. You understand the concept, at least then you can even test yourself. So that's really all that matters. Okay. Now cross it out. X minus 2 is the only thing. Yeah, exactly. X minus 2. So you're left with x minus 3 over x plus 5. No, row time, this is actually all I have. I have a degree in mathematics and a degree in finance. I used to work in a bank, and now I tutor people online. And I'm trying to get this stream going up much better. My Instagram notes are pretty popular, and I do lots of Discord calls with people, just like this, except for it would be private rather than on stream. Depends on the person. Yeah. Okay, are you ready to do question D? All right, yeah, you are. Okay, good. Okay, D. (10 plus 3p minus p squared). 25 minus p squared. Okay, I know you know how to do this one. Let's see it. Nothing's changed. Yep, SpongeBob idea is pay it forward. So that, like, if I can get it up running on Twitch and YouTube at the same time with better quality, then I have enough people who can afford to give money for tutoring, they do, and those who can't afford don't have to. So what does the numerator turn into? So the only thing I'm going to caution you before you go far ahead is that minus sign in front. So I'm going to give you a little bit of a trick. Take out a minus sign from the top first. You can even take it out of the bottom as well. So if I take a minus sign out of the top, we'll get p squared minus 3p minus 10. And if I take a minus sign out of the bottom, we'll get p squared minus 25 instead. And then a minus times a minus is a plus. So then we would just have p squared minus 3p minus 10 all over p squared minus 25. Do you see how I got to here? All I did was take out a okay. I didn't like the fact that there was a minus sign on the squared term. So I took out a minus sign on the top and I took one out of the bottom. Okay, so then we'd have two of them, and a minus times a minus is a positive, right? So then taking out from the top, you just change the signs on all of them. Taking out from the bottom, change the sign. Can you go from here to here? Okay. Can you see how we got to this part? Well, I didn't really work backwards or anything like that. I just didn't like the minus signs, so I took them out, and so it was easier to work with and rearrange. Because now you don't have to worry about that minus sign on the p squared, and just like now factor it normally. Yeah, I changed the signs because I took out a -1 from the top and from the bottom. So if I multiplied it back through, I would get the original. Okay, cool. Now factor the numerator and the denominator. Okay, so we've got what? Yeah, p minus 5 and p plus 2. And what do we have in the denominator? Yeah, so normally row time I go through Twitch. This is the first time just trying YouTube solely to see if how quality it is, because I'm still kind of messing with it. But my Twitch has the Streamlabs stuff set up. P plus 5 and p minus 5, yep. Okay. Well, remember, before you cross out, you have to state the restrictions. So what's the restrictions? Yep, it does become p plus 2 over p plus 5. So what is, we still need the restrictions. Well, if p is equal to minus 5, that's right. P is equal to 5, that's right. What about minus 2? The minus 2 doesn't matter, because it would just be 0 on the top, and then the bottom is just a number, so we'd still get 0. So remember, it's only the denominator that you have to worry about the restrictions. So do you see how it's just the denominator that's equal to 0? For the restrictions, like it doesn't matter what the numerator is. Cool. Cool. Now, do you think you can do the next two problems? Let's see. I want you to give them a shot on your own. See if you can write them down, and then we'll confirm afterwards. So I'll give you like... So yeah, I'll let you write it down. You write it down, write on your own piece of paper. And then you tell me what the answer is at the end. For E and F. See if you can do both of them. I'm gonna save these and kind of clean up a little bit, and then you tell me what the answer is. I'm not going anywhere. It's mostly a chance for you to see if you can do it on your own. And while I'm doing this, does anybody else have anything they want me to kind of just talk about, or? Because all I'm doing is going through and saving each one of these layers. Oops, here we are. Okay, that's all cleaned up. So, Road Time, are you still here? Yeah. So, if you guys are new here, basically what I do is I have a lot of stuff on my Instagram, and that's where a lot of this came from. So I make these images and then I post them on the Instagram. Lots of people like to ask me questions. They send me direct messages all the time, at any point in time in the day. And sometimes I can respond, and sometimes it'll take me a while before I can get to them, but it happens. So this is what I'm trying to build and do a bit better with, is these online tutoring. So I have a bunch of different things. I'm not sure what exactly I should go through at the moment, because we're just waiting for Buddy here to finish his questions. I did have a bunch of notes prepared for another thing that I was going to make, probably on stream, which is all about definition of derivatives. Just a bunch of notes. Okay, now he's working on it, so let's see if we can solve it real quick. E. T squared minus 7t plus 12. What is that? T cubed minus 6t squared plus 9t. What do we got? What do you do if it's cubed? First thing, if you remember correctly, is greatest common factor. There's a t in each of them, so take out an extra t. Not just a number, it can also be factored if there's a variable. So the t cubed, well, what's the numerator for start? Yeah, we got t minus 3 and t minus 4. Good. The denominator, we can take out a t, and then so we'd have t squared minus 6t plus 9, right? Now you can factor this normally. Do you see how we took out one t? Yeah. Mate's got it. So then this becomes, we've got the t minus 3, t minus 4, t, and then times what? So what does the denominator become? Yep, yep. My light's flickering. I know you got this one down. You should have it. Yep. So instead of writing t minus 3 times t minus 3, you can actually write that it's squared. So you would just write t minus 3 squared. It doesn't matter either way. It's just a little neater if you write it as it's squared rather than separate factors. So what happens next? What can cancel out? I left the t outside because it's all we did was take it out. It doesn't go away anywhere. Mate, it depends on the students. Who asks for a stream, because I don't really have a consistent quality right now, so I'm having trouble with it. But I'd like to stream as often as I could. I'm working on stuff every day, whether it's private calls, notes, or even just working in Photoshop here trying to make Instagram posts. I'm pretty much 12 or 13 hours a day. Gotta get it working somehow. Well, the t is a factor, so it came out because there was one on each of them, just like anything else. Like, nothing disappears unless it gets crossed out by something that's on the top, right? So it's still there. Okay, what's the restrictions? The 4 has nothing to do with it. Remember, it's only the denominator equal to 0, not the numerator. Try the restrictions again. Denominator. And this one here. There's the 3. T cannot be equal to 3. But if t itself is 0, makes it 0. So t cannot be 0. Yeah, can't be 0. Okay, so now let's cross out what we have similar on the top and bottom. What do we have similar on the top and bottom? No, the t is on the bottom. You're a little messed up here. So we're going to cross out the t minus 3 and one of them on the bottom. So now what are we left with? Okay. I'm going to write out what it's going to be while you're away there. We've got the t minus 4 on the top. And then since we still have a t and a t minus 3, we still have those on the bottom. Okay. I should probably turn it off in about 20 minutes here. And that'll have to do for today. I've got things this evening that I have to go. But people like the stream, so the more people that have questions, the more times I can stream. Otherwise, it's a little awkward just me kind of just sitting, writing stuff down. See if I can optimize it a little bit better for YouTube as well. I think YouTube seems to be a bit more popular than my Twitch for some reason. Maybe because of just the way YouTube operates with the algorithm. Does anybody else have anything they want to work on at the moment, or anything they want me to like maybe make something? Yeah, I know lots of people use YouTube more often. It's just that there's so much on YouTube, so much references. Like, there's tons of videos. Some are better quality than others, obviously, but I guess it's a stream is a nice feature because then you can literally just ask a question, because there's so many times where you don't even know what to look for because you don't know what you don't know. So it's interesting. Oh no, I just realized something. Oh, I just missed the playoffs for Overwatch League. Whoops. That's okay. I just assumed Vancouver won. Okay. Well, while we're waiting, I guess I'll open up a new one. Okay, no, interesting. I think it's time for a new overlay. And while we work on that, okay, well, but it's taken a little while. I'm using OBS as my broadcasting software. I honestly don't know too much about details. I just kind of know basics of what I needed to stream. Because I'm still learning so much about everything. Like, my mind was just blown this morning trying to think about a dynamic background. So using like a video loop for a background. So I've still got lots of things I want to remake and redo, and I've been making different pages here because this is all on Photoshop, right? That when I do the calls, I can save copies and send them to people, and they'll be printable. So I've still been working on lots of things. And then I just got Premiere, and I tried my hand at trying to make videos as well, which I don't feel are very good yet, but they're a start. For the first time ever using any software like that, I don't think they were too bad. So I don't know, it's all a learning process. If I can master quite a few of these things, I think this could be pretty big, pretty useful for a lot of people. Because so far, just my Instagram alone has 13,000 people following it. And I get students from all over asking me questions. And I just do direct messages most of the time. All right, bud. Let's see. Do you know how E was solved? Okay. The t minus 3 and on the top and 1 on the bottom, they crossed out. Right? So all that was left was the t minus 4 on the top. So just like anything else, it didn't disappear. We took it out because it was the greatest common factor between all three of these terms. All three of them. So we took it out. Okay? It doesn't disappear, it doesn't go away. If we multiply it back in, we get the original. Okay? Then we factored the t squared minus 6t plus 9, which gave us the t minus 3 times t minus 3, which is just t minus 3 squared. Are we good here? Perfect. Now, we crossed out one of the t minus 3's on the top and one of them on the bottom. So we're still left with t minus 4 on the top. And we still have the t on the bottom because that didn't change. And we have one of the t minus 3's left. So we have t times t minus 3. That makes sense. Cool. Okay. Did you attempt the last one, F? Or do you still need to do that one? Because I think I've got about another 10 or so minutes. Okay. We can do it together if you want. Or you can do it on your own, and maybe if you want, give it a shot. You could always just send me the answer on Discord afterwards if stream's done. Yeah, don't hesitate to worry about sending me a message whenever, even if it's on Discord or something. If I respond, I respond. If I don't have time, I will get back to you later, you know? So, you know what? I think you should give this one a shot. This last one, F. Okay. What's your question? Explain the second one. Okay. The triangle one? So, remember, what is... let me bring back up chat here. What is the area of a triangle? Just straight up. You have a triangle. What's the area of a triangle? One half base times height. Because base times height would just be like a square. So you would have one half of that for a triangle. So in this question here, let's see if I'm half decent at drawing. That's too perfect. Okay. In this triangle here, they've given you the whole base, which is 4x squared over x squared minus 16x plus 63. A hefty number, but they did it. And then they gave you the height, which I'm just going to draw as an arrow, which is 5x minus 35 over x plus 3. So now all I have to do is say that this is the base and this is the height. And you should be able to solve the rest of the problem because it's just filling in what we did. Okay, let's see. What's the other one? Ooh, such tiny text. Okay, again, this is another one where you just have to kind of make the formula from the information that's given to you. So first off, it says a rectangle. Well, let's draw a rectangle. A rectangle is 6 times as long as it is wide. Well, we're going to call this the width, and its width is W. And it's 6 times as long as it is wide, so 6 times W. Okay, that's not too bad. Determine the ratio of its area to its perimeter. Okay. What is the area? Oh, what is that? Holy cow. Thanks, bud. That was very unexpected. Oh, glorious. Thanks, bud. Okay. What is the ratio of the area? Not a problem, bud. Not a problem. What's the ratio of the area to the perimeter? What's the area of a rectangle? And then what's the perimeter? Yeah, length times width. And what's the perimeter? Perimeter is just the length all the way around, right? So it would be like W plus 6W plus W plus 6W, right? Yeah. So I'm going to write it as 2W, because 2 times the width, plus 2 times 6W, 2 times the length. So 2W plus 12W equals 14W. And then now you just need to do a ratio. Ratio of area to perimeter would be like area over perimeter. Yep, I actually was going to send them as soon as I was done here. They'll be straight to your Discord. Okay, so what's area over perimeter for this question? So 14W on the bottom. Yeah, 6W squared. So now you just simplify. Well, you just, yeah, so you just simplify. So 3W over 7. Because the W's will cancel out. One of them on the top for the bottom. So cross and cross. We got 6 is 2 times 3, and 14 is 2 times 7. So the 2's cancel. So 3W over 7. So there we go. How do you feel? Great. Go for it, bud. I'm going to send you these notes here, and then I'm off. These were the only 2 that I had left to save. You're very welcome, bud. And thanks for the donation, too. That was pretty unexpected. Yeah, confirm away. So I'm not sure what you mean, making the equation go from negative to positive to the power. So are you meaning like the one we did before? Because we had the, what was it? We had this. We had 10 plus 3p minus p squared. So for what we did here is the same as we've done all the way through, except for taking out like an actual number or something. We took out just a minus sign, or -1. So if we take out just a -1, we'll take out -1. That means everything that's left is the p squared, because we have to put the -1 back in to be able to go back to the original. Then the minus 3p, because if we multiplied the minus onto the -3, we get back our +3. And then we have a -10, because if we multiply the -1 back in, it becomes positive. Yeah, if there's a greatest common factor in it, you actually always take it out first. So like we did with the t cubed one, so t cubed minus 6t squared plus 9t, we had a t common in all of it. So we took it out first. Yeah, unless it gets canceled out. So for example, if I did this exact same thing, but I had t over it, let's see, t cubed minus t 6t squared plus 9t. The first thing you do is factor the t in the bottom, so nothing changes on the top. If you take out the t, you get the t squared minus 6t plus 9. And then now you can cancel them out. Do you see how that works? So just think about it as regular factoring. Doesn't matter if it's on the bottom or on the numerator. It's just regular factoring. Nothing goes away unless it has something to cancel with it. So you can think of it separately. Like what we did at the very beginning was just regular factoring. This is just regular factoring, but just one's on the bottom and one's on the top. So the one that had you confused was E, right? Yeah. This one. There was nothing that was any different. The top, the numerator, you factored just like normal. So you got that t minus 3 and t minus 4. Then you knew to take out the greatest common factor from the denominator. So you did that first. So that was the t. And so what you were left with was the t squared minus 6t plus 9, which is perfect. then you figured it out that it was t minus 3 times t minus 3, or just t minus 3 squared. That t that was in front didn't go anywhere, didn't have to change. And then you realize that one of the t minus 3's on the top cancels with one on the bottom. And that was it. Nothing else canceled out, nothing else changed. That was all that was left. It was we took the t out because it was the greatest common factor. No matter what is the whole thing, if there's a greatest common factor, we take it out. Yeah, so to speak. So, we're feeling good? No, because that's completely different. T minus 4 is one whole term. T is one whole term, and t minus 3 is one whole term. They're not the same, so you don't cancel anything. Think of it as like if I write it in parentheses, there's nothing left to cancel. Yeah, it has to have the exact same factor on the top to be able to cancel. So if, for example, it had a t on the top, yeah. There you go. Yeah, I'm going to check on that when I can. A buddy of mine sent me some notes on it, and I tried to go through it quickly, but they didn't line up. Yep, sure, no problem. You're very welcome for the help, bud. I'll send you these notes. I got them all. I got them all saved for you, and I'm just gonna head off to the rest of the stuff I gotta do tonight. And then we'll see what happens tomorrow as well. And I will work on some more stuff. Great. Great, great, great. Okay. I will catch you guys later. Thanks for tuning in. All right, bud. Just let me know. We can always go through more stuff anytime. Later, bud. And you know what? That's good for now.